Good afternoon, everyone. My name is Edward Anderson, and today I'll be presenting our research titled Enhancing Attention Span in Human Computer Interaction by Designing Digital Interface for Optimal Cognitive Efficiency. The study was conducted together with Henry Ricardo under the supervision of Andri Chowanda and Nikita Ananda Putri Masaling from Bina Nusantara University. Our research focused on how different user interface designs can influence people's attention span and mental workload when interacting with digital systems. Let's begin with the introduction. In today's world, digital technology is growing at an incredible pace, and with it, user interfaces have become an inseparable part of our daily lives, whether it's our phones, computers, or tablets. However, not all user interfaces are well designed. In fact, many of them are cluttered, distracting, or unintuitive, which can lead to cognitive overload. This means users become overwhelmed, confused, and mentally exhausted while trying to navigate digital environments. That's why the main aim for this research is to explore and identify user interface design principles that can help users reduce their cognitive load and in turn, allowing them to stay more focused and efficient when using a digital tools. The main objective of our research is to examine how different user interface designs affect both cognitive load and attention span. To do this, we compare two design styles, which is a minimalist user interface, which focuses on simplicity and reducing distractions, and a gamified user interface, which includes elements like rewards, animations, and playful interaction. Our goal is to evaluate how each style impacts user performance. So we'll be measuring variables such as task completion time, perceived workload, focus levels, and error rates. These metrics help us understand which interface helps user stay focused and which may cause more cognitive strain. Moving on to a literature review, Lawrence Breen and colleagues in 2019 found that people's attention spans are getting shorter and shorter as digital information moves and changes faster. This shows how important it is for interfaces to help users stay focused in a fast paced digital environment. Sweller introduced cognitive load theory, which explains that managing mental effort improves how people learn and perform tasks. This theory is central to our study because it connects directly to how interface designs can either reduce or increase cognitive load. Finally, Koch and colleagues in 2023 emphasized how important it is to measure mental workload accurately in human computer interaction, helping us to understand user effort more precisely. Together, these studies inspired our comparison between minimalist and gamified interface designs to see which one best supports user focus and efficiency. For methodology, we adopted a mixed method approach, combining both qualitative and quantitative methods to explore how user interface design impacts attention span and cognitive load. On the qualitative side, we began with a literature-based analysis. This involved reviewing existing research to establish a strong theoretical foundation. We examined past studies, focusing on topics like attention span, user interface design, and cognitive load. We also explored key human computer interaction theories such as Higgs law, Fitts law, and cognitive load theory to understand how users interact with different types of interfaces. To bring theory into context, we analyzed three widely used apps, which is Notion, Duolingo, and Google Keep, each with its own design philosophy. This helped us identify how real-world applications embody or diverge from established user interface principles. On the quantitative side, we developed a theoretical experimental design aimed at testing our hypothesis. In this experiment, we plan to compare two types of UI, which is minimalist and gamified. Participants would complete a series of tasks using each interface while we measure variable like task completion time, focus, workload, and error rate. For the analysis, we would apply a paired sample t-test to determine if the differences between the two designs are statistically significant. This mixed approach allows us to explore both the conceptual underpinnings and the measurable outcomes of different UI styles. Before moving to the results, let's look briefly at the two interface design used in our experiment. We have a comparison of the two interfaces. On the left, a minimalist user interface, which follows a clean and simple layout with neutral colors and very few decorative elements. The goal is to help users focus on their main task without distractions. And on the right, gamified user interface, which includes colorful visuals, progress indicators, and reward icons to make the interaction feel more engaging and fun. Both versions use the same task, which is drag and drop, so any difference in performance comes purely from design differences, not the task itself. Our results showed that the minimalist interface helped participants finish tasks significantly faster, on average about 13 seconds, compared to 17 seconds with the gamified version. This suggests that the minimalist design helps users stay focused and complete tasks more efficiently, likely because it has fewer distractions and simpler visual structure. Meanwhile, the focus scores, workload scores, and error rates between both designs were very similar, meaning that neither interface caused extra stress or reduced accuracy. And these differences were not statistically significant. In other words, both designs were usable and effective, but the minimalist UI gave a slight advantage in speed and mental clarity, while the gamified UI offered more engaging experience without increasing mental effort. So the main takeaway here is that simplicity improves efficiency, but engagement doesn't necessarily harm performance, as long as it's balanced carefully. Moving on to discussions, the faster task time for the minimalist user interface supports cognitive load theory, which says that removing clutter reduces the mental effort needed to process information. These align with Hicks' law, which explained that fewer choices help people decide faster. It also matches Fitts' law, which shows that clear, reachable buttons and elements help people interact more quickly and naturally. Interestingly, even though the gamified user interface added more visual elements, it did not raise the mental workload as we expected. Instead, it helped keep participants interested and motivated without making tasks feel harder. The very low error rates in both designs show that both interfaces gave clear guidance and useful feedback, which matches Norman's ideas about good usability, like clear visibility, feedback, and consistency. Together, these results suggest that a minimalist interface can help users finish tasks faster by lowering their mental effort, but both minimalist and gamified designs can keep users focused and accurate when designed carefully. In conclusion, our study shows that clean, uncluttered layouts improve task efficiency by lowering unnecessary mental steps, but adding gamified elements can keep users engaged without significantly increasing mental workload if balanced well. This means designers should find the right balance between simplicity and motivation when building interfaces for productivity or learning tools, where both focus and engagement matter. For future research, we recommend testing these ideas with larger and more diverse participant groups and using refined prototypes that match real world apps more closely. This would help generate stronger evidence and clearer guidelines for designers. That concludes my presentation on enhancing attention span through optimal interface design. Thank you for listening, and I hope this study contributes to future developments in user interface research.